Hi, boys and girls. This is Mrs. Roach back for another lesson in science in the solar system. So, before we get started, I just want to make sure that you are ready for learning, and we're going to get started. Okay, boys and girls, we're going to be continuing lesson 1 on movements of the Earth, Moon, and Sun systems. And so last week I introduced this lesson to you guys. And then this week, we're going to learn some more about these systems. So our essential question is, how do the sun, Earth, and the moon interact? If you remember from last week when we introduced it. And so we're going to be able to answer this question by the end of this lesson. So let's get started. All right, we have 2 objectives today. I can show how changes in Earth's position affect conditions at different locations on its surface. I can acquire new vocabulary words and identify them in a text. And so we're going to be learning some new vocabulary words today and their definition, their meanings. All right, so here are our new vocabulary words for lesson 1. We have 5 vocabulary words that we're going to use to explain about movements of the sun, the earth, and the moon. We're going to use them to explain concepts. And so our first word is orbit, revolution, gravity, rotation, and inertia. And just take a look at these vocabulary words, boys and girls, and see if you recognize any of these words or you know the meaning of them. And for most of us, these words are going to be new vocabulary words that we're just learning. All right, so boys and girls, I'm going to introduce the definition for our vocabulary words. And as I do this, I'm going to say pause and have you write down the vocabulary word and the definition, okay? So when you hear pause, you may pause the screen, and if you have your science notebook, you can write the vocabulary word and the definition in your notebook. Our first word is orbit, and it means the path one object travels around another object. And so when we talk about the Earth and the sun, our Earth, we're learning about orbits the sun. It travels around the sun, okay? So please pause and write down your first vocabulary word and the definition. Okay, our second word is gravity. And this might be a familiar word to some of you boys and girls from last year. It is the force of attraction between any 2 objects due to their mass. And so if you look over here, gravity on Earth, boys and girls, it pulls objects downward, okay? So look at the apple tree. When the apple falls off the tree, the apple's being pulled to the ground because of the gravitational force on Earth. And we're going to learn more about that later. So we'll return back to that word. So please pause and write down your second vocab word and the definition. Okay, moving on. The next word is called inertia. And many students may have never heard that word before, might have not heard that word. It is the tendency of moving an object to keep moving in a straight line, or any object to resist change in motion. And so here's an example I found for you, boys and girls. A ball will roll on the floor until it hits another object. And so if you would take a ball and just roll it across the floor, it's going to stay in that straight line until something else interferes with it. And that basically is inertia. And we're going to talk about that. We're going to read about that in the text today. And Mrs. DeMarco is going to share with you in the next video lesson a short demonstration about gravity and inertia as well. So you'll get to see that. All right. Our last 2 vocabulary words are revolution and rotation. And these 2 words can be mixed up sometimes. So listen to their definitions, and then I'm going to show you I'm going to give you an example. I'm going to show you an example of both. Revolution is one complete trip around another. And a rotation is a complete spin on an axis. And so I'm going to just quickly use my chair in my office here at home to show you what I mean. And so you can see the difference between a revolution and a rotation. So if I were to take one complete trip, walk around my chair, that would be a revolution, okay? And then a rotation is my chair can turn, and so it can rotate. And so if I spin all the way around, that would be a turn all the way around on its axis, that is called rotating. So that is just an example of both of those words in action. And we're going to read about how the earth and the sun, the earth rotates and revolves around the sun in this lesson. So stay tuned. All right. This is called this paragraph, this title is called the solar system. And so please read along with me as I read this aloud. And I want you to look for any vocabulary words that I just introduced to you. And I would like for you to be ready to answer some questions based off of what we read. The sun and all the objects that orbit around it make up our solar system. The sun has many satellites. A satellite is any object that orbits another larger body. An orbit is the nearly circular path that an object travels around a larger object. The moon is a satellite that orbits Earth. On a clear evening, you may see a planet or two in the sky as well. A planet is a large, round object in space that orbits a star. Planets in our solar system, including Earth, orbit the sun. So I'm going to go through, boys and girls. I'm going to ask you some questions. We're going to highlight some important information here. So what is an orbit? And look back in the text. I hope you were able to look back and find, I'm going to turn my highlighter on, that an orbit is the nearly circular path that an object travels around a larger object. Okay? Also, what did they say a planet? What is a planet? Yes, a planet is a large round object in space that orbits a star. And so this last sentence is also important. Planets in our solar system, including Earth, orbit the sun. Okay? So let's take a look here what that looks like. Here we have Mercury, Venus, Earth, and Mars. And you can see that they are orbiting around the sun, okay, going in that circular elliptical path. And boys and girls, the reason why they're showing you Mercury, Venus, Earth, and Mars is that these planets, these 4 planets, boys and girls, besides Earth, the other planets are able to be visibly seen at night. So if you go out on a really clear night, you may be able to see one of these planets up in the sky without a telescope. So that's very interesting. All right. So then what is an orbit? Well, we found in the text, if we look back, an orbit is the nearly circular path that an object travels around a larger object. Okay? And so our Earth orbits the sun. Very good. All right, so let's check our predictions from last week. How are the planets arranged? Okay, so here we have, so last week, boys and girls, many of you said that they are arranged from nearest to farthest from the sun. So very good. And so here, this is the arrangement of the planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And so Neptune being the furthest from the sun. And you also, many of you also put in your responses that temperature was different depending on what planet or how close the planet is to the sun. So I thought that was really great that some of you were able to say that in your responses. All right. Now we're going to read about gravity. What did we say gravity is? Well, gravity, boys and girls, is a force of attraction or pull between any 2 objects, okay? And so when we talk about the pull of gravity, it depends on the total mass of the 2 objects, okay? And I would like for you to pause this screen and read some more about gravity. Read these 2 paragraphs to yourself about gravity, please. So please pause and read. Okay, I hope you're able to read about gravity on this slide. So boys and girls, what is the largest object in the solar system? If you can look back in the text. Very good. It is the sun. Our sun is the largest object in space, in solar system. And just about how large is it? How many Earths does it say in the text that you could fit across the sun? 109 Earths would fit across the sun. Very good. And so the more massive an object is, the stronger its gravitational attraction. And so this last sentence is also important. Gravitational attraction holds the entire solar system together. Okay, so that's a key idea we want to highlight. All right. So how many times larger did we say the sun is compared to the Earth? 109 times. So look at the Earth here and how it compares to the sun. There, you could fit 109 of our size Earth, the size of our Earth, 109 of them around the sun. So that's pretty interesting to think about the scale of the Earth compared to the sun. We are very tiny compared to what the size of the sun. All right, so what would happen, boys and girls? We just talked about gravity, okay? We just learned the meaning. What would happen to Earth, if gravity was the only force, okay? The only force. So look at this diagram here, okay? We have the gravitational pull of gravity on Earth, and we also have a force which is called inertia, boys and girls. This is another vocabulary word. And without inertia, our Earth would be pulled directly into the sun. It would be pulled directly into the sun. And so for this to not happen, we need inertia. And so inertia, we said, is the tendency of an object to keep moving in a straight line. And so if you look up here, you can see inertia. And as Earth orbits the sun, it is pulled toward the sun because of gravity. But at the same time, Earth's inertia makes it move away from the sun. And together, these factors produce Earth's nearly circular orbit. Okay, so both of these factors are forces, I should say, are balancing Earth out so that it stays put. All right, so here is a nice diagram showing you the sun. Here's planet Earth. And so just gravity would pull the Earth directly into the sun. So we need inertia over here. Inertia alone, however, would move Earth in a straight line this way. And we do not want that either. That would not be good. So it is these two forces balanced together. See this yellow line? Gravity and inertia together make Earth follow this path, this orbit path around the sun. And that is not a perfect circle. And so gravity and inertia keep Earth and all the other planets in orbit around the sun. All right. So I would like for you to pause. I'm going to read this question and I'm going to have you pause and respond in your notebooks if you have your science notebook. So how are gravity and inertia involved with Earth's orbit? Please pause and try to answer this question based off of what you just learned. Okay, I hope you were able to answer with some of these ideas. Gravity pulls Earth towards the sun. Inertia keeps Earth moving in a straight line. This balance results in Earth's orbit around the sun. So I hope we were able to conclude that from what you read today. All right, now we're going to talk about the gravitational pull and how it affects Earth and the moon. Okay, so here, and it looks like I'm on the moon here. Here is a picture that an astronaut took when he landed on the moon. And so we have had astronauts land on the moon, boys and girls. And so someone took this picture. It's an actual footage of what the Earth looks like from the moon's perspective. Okay, and so let's go right over here and read about the gravitational pull, or force, I should say, on the moon. And so it says the moon is less massive than Earth, so it has a weaker pull of gravity than Earth. In fact, the moon's gravity is about 1/6 of Earth's gravity. Think how high you can throw a ball. On the moon, you could throw it about 6 times higher because the force of gravity is not as strong. Okay, so that's pretty interesting to think about. It would be 6 times higher on the moon because the gravity is not as strong as Earth. All right, we are going to watch a short video clip about the gravitational force on the moon. And we'll talk about it after you watch it.
Ah. Why do you weigh less on the moon? Huh? Ah. Hey, what are you doing? It is not possible. You cannot fly on Earth. Please listen. Ah! Look, I had warned you. Now, why don't you try the same activity on the moon? There, you will weigh much less, and thus, you can fly short distances. Huh? See? I was correct. Do you know why you weigh less on the moon? To understand this, we need to first learn about weight. Now, not those weights. Weight is the force with which an object is pulled towards the center of the Earth or any other celestial body. This force is called the gravitational force. Huh? Greater the gravitational force exerted by the celestial body, more will be the weight of an object present on it. So, does this mean that the moon exerts less gravitational force than the Earth? Oh. Bingo. You are right. But do you know why? This is because gravitational force is directly proportional to the mass of an object. Greater the mass, greater will be the gravitational force exerted by it, and thus, more will be our weight. As the moon has lesser mass than the Earth, it has a weaker gravitational pull, and hence, we weigh less on the moon. Are you still using Google?
All right, boys and girls. So we're now going to read about how Earth's gravity affects the moon. I'm going to read this paragraph aloud. Please read this with me. Earth's gravity affects the moon, and the moon's gravity also affects Earth. The moon's gravitational force causes Earth's tides, the regular rise and fall of water levels along the shore. So I'm going to highlight this, boys and girls, because this explains how the gravitational force and how it affects Earth. And so if you've ever been to the shore or the ocean, the gravitational force is responsible for the tides that you see coming in and out at the ocean. And so if you look down here, boys and girls, you see an astronaut who landed on the moon. And if you can see, I highlighted his feet here to show you how he's actually jumping 6 times higher than he could on Earth. And so it's hard to tell from the picture, but it's a pretty cool picture. All right. So let's think and respond to what we learned about how gravity, the moon's gravity affects Earth. I'd like you to pause and jot down your answer. So please pause. Okay. I hope you were able to conclude that the pull of gravity between the Earth and moon causes Earth's tides, what we just read about in the text. So we're going to move on, boys and girls. You're doing a great job. Our last two new vocabulary words for this lesson, we're going to talk about our revolution and rotation. And remember, I showed you when I did a complete trip around my chair, that's a revolution. And if I turn or rotate on the chair, that's a rotation. So I would like for you to pause and read this paragraph independently. And we'll talk about it afterwards. So please pause. Okay, so when we talk about what is the difference between revolution and rotation, well, here in the text, how long does it say that it takes Earth to revolve around the sun? That's correct. About 365 days, or we call it a year, 1 year. And so how long then does it take for Earth to do a complete spin or rotation? Very good. About 1 day for one rotation takes about 24 hours. And so, boys and girls, we do not feel the earth rotating or revolving because we are also moving with earth. And I know it's hard. It's a hard concept to grasp. All right, so here is a nice diagram showing you Earth's rotation, which takes what we just learned. How long? 24 hours or a day. And here's a diagram showing you Earth's revolution as it orbits around the sun. Oops, sorry. And how long did we say that it takes for a complete revolution? Very good. About 365 days or 1 whole year to revolve around the sun. And so I'd like you to make some predictions. What do you think, what factors are changing on Earth for us as the sun makes its revolution around, as the Earth, makes its revolution around the sun? What do you think is changing for us on Earth? We're going to return back to that question. What is the difference between revolution and rotation? Well, we just found in the text that the Earth's revolution around the sun takes 365 days, and the rotation takes 24 hours or 1 day. Very good. And so we're going to return back to that question I asked about what causes the seasons to change on the northern hemisphere. So I would like for you to keep the vocabulary word of revolution in your mind as you're watching this video clip about what causes the seasons to change. And boys and girls, we are on the northern hemisphere. So when they're talking about the northern hemisphere, they're talking about where we live.
Summer, fall. Seasons. I just love them all. Other than inspiring me to make up goofy poetry, why wouldn't you love the seasons? There's always something to look forward to. You already know that summer means long days of fun in the sun, and winter means shorter days, not to mention building snowmen and making lots of Frozen references. Okay, so clearly the sun and seasons are linked. But how? You already know that the sun is pretty important. It is the center of the solar system, after all. You also know that our planet, Earth, revolves around the sun, making its orbit once every 365 days. And remember, Earth isn't taking that lap while it's standing straight up and down. Instead, it's tilted on its axis, the invisible line around which our planet spins. Put together, the Earth's tilt on its axis and the orbit it makes around the sun, and you get the yearly pattern we call seasons. Let's see how. Since the Earth is tilted, for part of the year, one of the hemispheres, which is half of the Earth, is leaning toward the sun, and the other part of the year, it's leaning away. Let's follow the northern hemisphere once around the sun to see how this works. In June, the northern hemisphere is tilted towards the sun. This means that it's getting a lot of direct sunlight, light that's hitting it straight on. If you ever sat directly underneath a bulb, you know that things can get pretty hot, and that's exactly what's happening to the northern hemisphere. It's summertime and the living is easy. Temperatures are warm and days are long. In December, though, the northern hemisphere is tilted away from the sun. It's getting indirect sunlight, meaning light is hitting it at an angle. Indirect sunlight means cooler temperatures, shorter days, and, for lots of folks, hot cocoa and bundling up since it's winter. But how can the angle of the sun's light make a difference between hot and cold? Well, try this little trick with a flashlight. Get a flashlight and dim the lights in your room a little bit. If you turn the flashlight on and point it straight down onto your desk, you'll see a small, bright, concentrated circle of light. That's kind of how sunlight hits the northern hemisphere during the summer. Bright and intense. Now move the flashlight down at an angle and point it at the top of your your desk. See how the light isn't as bright and is less intense where it falls? That's like the sunlight we get in winter. But what about spring and autumn? During these two seasons, the Earth's orbit causes the northern hemisphere to be neither tilted toward the sun nor away from it. So temperatures during the spring and fall are more moderate, not too hot and not too cold, since the entire globe is getting about the same amount of direct sunlight at once. Now, let's take a look at how the amount of sunlight affects temperatures in the northern hemisphere over the course of a whole year. An easy way to show this yearly pattern is by using a graph. This graph shows the average high temperature in each month for 1 year in Toronto, Canada, where I live. Looking at the graph, we see that during December, January, and February, when the northern hemisphere is getting very little direct sunlight, temperatures are low. And in the months of June, July, and August, when the tilt of the Earth on its axis is causing Toronto to get direct sunlight, the temperatures are much higher. Proof positive that something is going on here, and that something is this. The season that you're experiencing right this very minute is caused in part by the amount of direct sunlight you're getting. So, seasons are caused by the Earth's tilt on its axis as it cruises around the sun in its orbit. When one hemisphere gets more direct sunlight, it's summer there. Temperatures are warmer, days are longer, and nights are shorter. And when it gets more indirect sunlight, it's winter. Temperatures are cooler, days are shorter, and nights are longer. And now you know what causes summer, spring, autumn, and winter.
All right, boys and girls. So we're going to return to our question. What causes the seasons to change on the northern hemisphere? So we're going to think about that. What causes the seasons? What did you learn from the video to change on the northern hemisphere? So please pause and try to answer this question based off of what you've learned. Okay, I hope you were able to conclude that the Earth's tilt on its axis and its revolution around the sun causes the seasons to change for us here on Earth. And depending on where you live on Earth, that can differ also, what kind of seasons you experience. All right, we are going to return to our page, Keely. Sorry about that. Trying to navigate this. Okay, so I told you we would return to our page, Keely, to see if your thinking has changed after we learned our lesson. And so here it says Emmy and Dexter, if you remember from the beginning of the lesson. And so who is actually correct? Who should you have agreed with? That's right. Emmy was on the right track. I think the Earth moves around the sun. And that is because Emmy is correct, because the Earth, in fact, orbits around the sun, as we have been learning about. All right. And so our last activity today, to wrap up what we've been learning, is we're going to do a short fill in the blank activity. So I'm going to read the sentence, and I would like for you to use this word bank down below to fill in the missing word to wrap up the main ideas that we've learned in lesson 1 to answer our essential question. How does the sun, earth, and the moon interact? So we're going to answer that now together. All right, so here we go. Number 1, the earth rotates and revolves around the blank. What belongs there? The sun. Very good. 1 second, boys and girls. There we go. The sun. Oops. Okay. This causes the blank to change and the length in daytime and nighttime to change depending on where you live. What belongs in the missing space? Seasons. The seasons to change. Very good. Number 2, the sun, the earth, and the moon are held by blank. Gravity. Very good. We're on a roll here. Number 3, the moon orbits the blank? Earth. Very good. We also learned it's the only natural satellite that orbits the Earth. Very good. The gravitational pull on Earth causes the Earth's blank. Tides. Very good. And our last one, the blank is the center of the universe and all planets orbit around it. Process of elimination, the sun is the center of the universe. All right, boys and girls, that wraps up lesson 1. Mrs. DeMarco will be sharing with you a mini demonstration on gravity and inertia. And so you'll be watching that video next. Please just make sure you're doing your assignments, and I will see you next week. Bye-bye.